Dear colleagues and participants of the conference, my name is Viktor Zhukovsky and I would like to present our scientific research regarding development of model predictive control algorithm for managing deformation of multilayered soil massive under mass and heat transfer. Soil is a heterogeneous environment that naturally consists of multiple layers such as sand, clay, loam, humus and chernozem. Previous studies have investigated the process of filtration, mass and heat transfer and stress-strain state in soils in the presence of pure water. However, in natural conditions, various saline solutions are also filtered, and also there is an effect of temperature. Filtration is slower in clay soil layers and faster in sand, and we have to take into account these factors. These processes can also affect the stability of facilities built on such soils and result in unpredictable accidents and significant economic losses. That's why the mathematical and computer modeling can be used to study these processes. And we can use the three-dimensional modeling, allowing us to build an adequate physical description of process and allow us to analyze the process in the future. So, let us formulate the problem. We are considering the multilayered soil massive with a free surface in the three-dimensional case, as described on the figure number 1. The special scheme of the multilayered soil massive with the free surface. There are n soil layers, which is numbered from bottom to top, in the area omega. Also, based on this physical formulation, we build the mathematical model, which consists of equilibrium equations in the form of Lamé for soil massive displacement, based on the generalization of Hooke's law, taking into account heat and mass transfer and dependencies of Lamé and Young modulus coefficients on salt solution concentration and temperature. All these equations are numbered with number 1. Also, we may see the components of the mass forces in all layers of area omega with number 2. Cauchy relations expressing the dependencies of normal and tangential strains components on displacement components are presented by equation number 3. The normal and tangential stresses based on the generalized Hooke's law in inverse form and the law of partially tangential stresses taking into account the dependencies of Lamé coefficients are presented by number 4. Also, we have the boundary and congestional conditions for displacement and stresses, which take into account the thermal and chemical states of the soil massifs. We have results of physical experiments, and that results allows us to build the following dependencies of the Young's deformation models and Lamé coefficients for salt solutions, which depends from concentration and temperature. We see all that dependencies on the next 4 equations. So, figure 2, for example, describes the dependence of the filtration coefficients on the concentration of the filter solution and temperature. So, the nonlinear dependence from 2 parameters. And after the series of numerical experiments, which we made with the area omega, which is rectangular form, which took the length 10 meters, thickness 10 meters and height 10 meters, the free surface located at the level 7 meters, and under the area of clay soils has a height 3 meters with the following initial data. After a series of such numerical experiments, we got the next just few results which we described here because of the lack of time. For example, if this feature describes the distribution of displacements in cross-section by plane YOZ, by plane XOZ, and by plane XOY. So these are distributions of displacements. So let us summarize. The physical formulation of the problem of spatial deformation processes in a multi-layered three-dimensional case was formulated, and also the mathematical model is constructed. As a result of numerical solution and computer modeling of the required function displacements, normal and tangential deformations and stresses were obtained, which made it possible to estimate their values in different subregions of the soil massive. So we can also say that the analysis of obtained results demonstrates thus that the largest values of spatial displacements are achieved in the subregions of water-saturated sandy soil. In the subareas of clay soils, the displacements are smaller than in sandy, water-saturated ones, due to the slow passage of pollution, filtration, and mass heat transfer. That's all for our presentation. Thank you all for your attention, and we are open for constructive discussions. Thank you.